Hi everyone, and welcome to our video on solving trigonometric equations that are in quadratic form. So if we have a quadratic, it doesn't matter if it's just regular letters like this one here where I'm swirling around that we might have seen in a algebra or pre-calculus class, or if it's other variable expressions such as trig or logarithms or exponentials. So they all factor the same way. So for instance, if we're solving this equation, number one, cosine squared theta plus 2 cosine theta minus 3 equals 0, it has three terms. This is very much just like a variable squared. So cosine theta squared is just like x squared plus 2x minus 3 equals 0. And so we would factor this the same way as we factor the trig function. So this would get factored as x and x. So I like to set up our first term. So I know x times x would be x squared. And then I need to figure out, well, I have a minus 3. So one of these has to be minus and one of these has to be plus. And then I just have to make sure I put the 3 and the 1 in the right spot. Okay, so 1 times 3 is the way to get 3. And then anytime you factor, you can check with redistributing it out to see if it matches above. So for instance, x times x is x squared. Positive 3x minus 1x is positive 2x, and then negative 1 times a positive 3 is negative 3. So that means our equation, let me rewrite it down below a little bit. That means our equation here factors the same way as that, except instead of x, it's cosine of theta. So we would factor it as cosine of theta minus 1 and cosine of theta plus 3. In parentheses, set equal to 0. And now that we have expressions factored and set to 0, we can separate them individually and have them set equal to 0. So cosine of theta minus 1 can be set equal to 0. Cosine of theta plus 3 can be set equal to 0. And then we can get our trig function by itself. So on the first one, we'll just add the 1 over. On the second one, we would subtract the 3 over. Now, this second one, let's start with that. Cosine of theta equaling negative 3. Remember, that's an x-coordinate that they're saying you're trying to find, and then work backwards to get the angle. Well, an x-coordinate of negative 3 is somewhere over here. It won't be on the unit circle. All right, so I put a big dot down, but I'm going to erase it to put room. So remember, cosine's smallest value is negative 1. Its biggest value is positive 1. If it's not in that range, we would then not have an answer. Okay, so this one has no solution. So I'm just gonna slash it out, no solution, which is fine. We just move on. So we don't care about this one anymore. However, cosine of theta equaling 1, well, I'm looking for the x-coordinate of 1. It's right there in my big old dot that I drew, and then, well, the angle for it is 0. So that is theta is equal to 0, and then, like usual, they want all solutions, so we would do plus 2 pi k. Or they might just say your answer is 2 pi k. Okay, because you don't need to show 0 plus, but I kind of like to. And then that's it. Okay, so we could double check it. If I plugged in 0, let me do that in the purple right below. So if I plug 0 into our trig function for theta, well, cosine of 0 is 1. So this would be 1 squared plus 2 times 1 minus 3. Yeah, that does equal 0. 1 plus 2 minus 3 is 0. So that looks like our answer is good. All right, number 2. Now, you could set it up in a similar way that we did in this first one. However, I'm going to try to do this without an x. I'm just going to say, how about we try to use the trig functions on their own? So I'm still focusing on this. It has 3 terms, and I see a square variable, and I see a non-square. So that means it should factor into 2 binomials. So in those binomials, let's give ourselves plenty of space. There we are. I know the first term in each of these has to multiply to be 2 sine squared theta. The only way to make that happen is, well, I know 2 times 1 is the way to get the 2, and then sine of theta times sine of theta is the only way to get sine squared. Okay, so those have to be the first terms. And then I focus on the last term, the -4. So I like guess and check because they often don't give very hard numbers. And if we get used to factoring with guess and check, we're going to save a lot of time in the future. Especially if you have to take calculus, there's a lot of factoring there still. All right, so I'm looking at this -4 and I'm thinking, all right, I know I need a positive and a negative to make a -4 when multiplied. My options for -4 are 1 and 4 and 2 and 2. All right, well, I also need to make sure it does add up to +7 eventually. Well, the guess and check, so you might see it right away, but we know, for instance, I know so I'm going to erase this in a second. So it doesn't matter if this first one's plus or minus if I'm trying to use 2. So here I'm taking the guess 2 times 2 is 4. But notice I would have a common factor of 2 in this scenario, which means we could have factored out a 2 from the start. So that means this can't be a 2. Okay, so a plus or a minus, it can't be 2. So that means my only option is 1 and 4. And even if I did try 2 and -2, I mean, the checking part would verify it. All right, so I need a 4 and a 1. All right, so I see, again, also, look at this. If I put a 4 plus or minus 4 right here, that means this 2 and that 4 could have been factored. So that means I could have factored a 2 from the start, which I could not have. Okay, so that means I can't do 4 there either. All right, so even with guess and check, the guessing can get narrowed down by just looking at what could happen. Oops, let me maybe not do minus yet. So I know it's got to be a 1 here and a 4 here. And then I'm just thinking, okay, how do I get a +7? Well, I think it's a -1 and then a +4. And then now I'm just going to check. Okay, so let's multiply this out. So I'm going to check it above, so to keep the flow of the problem below going well. When we FOIL, notice I would have 2 sine theta times 1 sine theta is 2 sine squared theta. And then 2 sine theta times +4 is +8 sine theta. -1 times +1 sine theta is negative sine theta. -1 and +4 is -4. Notice these two combine to give us the middle term. And then the other 2 terms are there as well. Okay, so that means we factored it correctly. And now that it's factored correctly and set equal to 0, we can split each factor and have them set equal to 0. This first one we can solve by adding the 1 over and then dividing by 2. So we would have sine of theta equals 1/2. And then the second equation we could solve by just subtracting the 4 to both sides. And then the sine of theta equaling -4, it's kind of similar to what happened with the cosine of the previous problem. We can't have sine of theta be -4 because that's a y-coordinate. So -4 as a y-coordinate is not on the unit circle. So that means that one we don't care about. That happens quite a bit in these factoring problems where one of them kind of gets just thrown out. All right, but this other one is good. Sine of theta equaling 1/2 would be in quadrant 1 and quadrant 2, close to the x-axis. So that's our pi/6 and 5 pi/6. So our answer for theta is pi/6, and then we're assuming we're solving for all answers, all solutions. So then we'll do plus 2 pi k, and then comma, 5 pi/6 plus 2 pi k. And that's it. And then like the previous problem, we could check it. We could plug in pi/6. It will work. All right, so if you do want to double check all of it, go for it. But I'm going to say I think we can be done with this to save a little time. All right, so that's our factoring. So again, the main thing with these trig ones is don't let them freak you out. It's just like the same thing as if it was x. And you can rewrite it the same way like I'm currently swirling around if you want to the side. But I would try to get used to the trig functions without changing their letters. All right, so thanks for watching. If you do have any questions, please let me know.